Welcome back. In the previous session, we have seen the finite state machine for the data transfer in TCP from the sender side. Now we'll try to see the FSM for the data transfer in TCP from the receiver side. Now in the receiver side, when the data is received by the receiver, that is an expected error-free data or error-free segment is arrived, it will buffer the message and then it will acknowledgement time delaying timer is running. It will stop the timer and send an cumulative acknowledgement, else it will start the acknowledgement delaying timer, because it has to wait for the other segment to be sent. If there is no data is to be sent now, so it will wait for a 500 millisecond something kind of a thing, or it will wait for a delaying timer. Now because it is in ready state, if the we'll go by one by one of the scenario. If acknowledgement delaying timer is expired, suppose if the receiver is waiting for the receiver to send any of the data to the sender side, and in the meantime the acknowledgement delaying timer that has been initiated by the receiver, it is expired, then it will not wait further for the receiver to send any of the data to the receiver and piggyback the acknowledgement. It will immediately send an independent acknowledgement to the sender. Second case can be if an error free but out of order segment is arrived. If suppose there is a segment expected for the number 3, and if 4 is arrived, then it stores that segment. If it is not duplicate, for example 4 is received for the first time, then it will store it in the buffer or in the queue, and then it sends an acknowledgement saying that sequence number 3 is expected. Again it will initiate a duplicate acknowledgement. So that is one more scenario. Then if a corrupted segment is arrived, as I said, if the checksum is not correct, then it will discard the segment and it will again go to the ready state. Then an error free duplicate segment or an error free segment with the sequence number outside the window is arrived, then it will discard the segment. That is if an error free duplicate segment, that is if it is error free also, but if it is a duplicate segment, or if it is a segment which is not expected now or outside the window, if it is arrived, then it is discard the segment and sends an acknowledgement with the sequence number of the expected segment, because we are getting a duplicate segment here. Then a request for delivery of k bytes of data from the process came. Suppose if the TCP is in ready state and all of a sudden the process says ki send the data, process of the receiver says the send the data from the transport layer to the application layer, then of k bytes, then it will deliver that data and slide the window and adjust the window size. Means it vacates the buffer of the data that is around k bytes which has been sent to the process. So the receiver window will vacate k byte amount of data, so that the next data can be received by the receiver. So this is a scenario where we can understand the data transfer in TCP at the receiver side. Now we'll see some of the scenarios where we are talking about the normal operation. Now here we'll try to understand the whole process more clearly. For example, if the client is sending a sequence number from 1201 to 1400 to the server, means it is actually sending a data and it is acknowledging the 4000 segment that has been sent by the server to the client. So it is acknowledging it as 4001 because the next segment that is expected by the client is of the number 4001. So once this data that the client want to send with the acknowledged number 4001 is received by the server will initiate the next sequence. That is, the receiver is expecting, or this client is expecting 4001 number of sequence. So it will start with 4001 till the next end of the segment, and then it will try to send this whole block to the client, and then it is acknowledging that 1400 till 1400 I have received. So it is expecting now, server is expecting now 1401 data to be sent by the client. So acknowledgement is sent for the next data to be sent by the client, and the sequence number from 4001, which was expected by the client, till 5000 is sent by the server to the client. Now here the acknowledgement delaying timer is initiated. So once it is initiated, it will wait for 500 millisecond. After 500 millisecond, the client understands that there is no data that has to be sent from the client side to the server side. So only acknowledgement is initiated. You can see that here this with the sequence number or with the segment or with the data, the acknowledgement number was initiated for the previous data received as 1400. But here, because there is no data has to be sent from the client to the server, only the acknowledgement has been initiated for the previous data that has been received. Up to 5000 we have received. Now 5001 is expected from the server, so 5001 is sent from the client to the server. Now if 5001 to 6000 is sent by the server to the client, and in the meantime again 6001 to the 7000 is also sent to the client, and there is no data which is received from the client to the server, then it will acknowledge again 1401, because from after 1401 acknowledgement there is no other data is received from client to the server. So still it is expecting 1401 data to be sent from the client, and if it is sent before the timer expires, then the timer stops and immediately it sends the acknowledgement for the latest data that has been received. The latest data that we have received is from 6001 to 7000. So instead of sending the acknowledgement for 6000, it will directly send the acknowledgement for 7000, which is a cumulative acknowledgement. So once 7001 acknowledgement is sent back to the server will understand that 6000 is properly received, as well as 7000 is also properly received by the receiver. Now this is an example where we are talking about the loss segment. Suppose if a sequence number from 501 to 600 is to be sent from client to server, and this is the receiving buffer. So this segment is received by the buffer, and then again 601 to 700 is sent by the client to the server. So because this is also received, this is also received, so two segments are received, those are stored here properly in the receiver buffer, and immediately 701 is sent, because 700 till 700 the data is received. So once we send 701 as acknowledgement, it ensures to the client that up to 700 we have received the data, or the server has received the data properly. So immediately the timer will stop, which was initiated when the sequence number 501 is sent. So after that again it will initiate the RTO, and once the RTO is initiated, the sequence number from 701 to 800 is sent, which is somewhere lost in the network due to congestion, and after that again 801 to 900 is sent to the server, but 701 to 800 is lost somewhere in the network. So again it will initiate an acknowledgement of 701, because this 701 is not yet received by the server, So acknowledgement 701 is sent to the client. Now the client, after the timeout, will understand that there is no acknowledgement received for the previous data which is sent, that is up to 800, and only 701 is received by the sender. So it will again reinitiate or retransmit the sequence from 701 to 800, and once it will received by this, now because already up to 900 the server has received the data, so it will immediately initiate an acknowledgement of 901, and if the timer is restarted, then it will stop once it receives the 901. So here, because the data was lost, it waited for the timeout, and after the timeout again it resent the data to the server. So this is when the loss segment is occurring in the whole scenario.